Today's lesson is about motions. Suppose that a particle moves along a straight line, and we are going to sketch the graph of time versus the position. Time is t on the horizontal axis, and position is on the vertical axis. So we are at t1, and then the particle goes to t2, and the position varies from x1 to x2. So in the period of time between t1 and t2, the particle moves from x1 to x2. How fast this happens determines the velocity of the particle. Therefore, the average velocity is the slope of this red segment. Once t2 gets closer and closer to t1, it becomes the slope of tangent line, which is the velocity at a moment, or instantaneous velocity. Therefore, if xt is given, which is the position, we can claim that velocity is dx over dt, or simply x prime t. So it means if you take the derivative of the position, it's going to be the velocity of the particle. Likewise, as you know, acceleration means how fast velocity changes. So it means acceleration also is the derivative of velocity with respect to time, or simply v prime at t. Let's have an example. Xt is t squared minus 2t plus 5. This is the equation of the position regarding a particle that moves along this straight line. So the question is, at t equals 0, what is our position? That's simple, because by plugging 0 here, you get 5. So it means at t equals 0, we are 5 units at the right side of the origin. For example, if the origin x equals 0 is the origin of the position, at time t equals 0, x is 5. So what happens after, for example, 1 second, or it depends on what unit of time we are dealing with. But let's say 1 second. So x of 1 is going to be 1 minus 2, so plus 5, which is 4. So it means when t equals 1, after 1 second, you are getting back to 4 here. So therefore, xt gives you the position of the particle at any moment. So I'm interested to find out what is the velocity of this particle, for example, after 2 seconds. As we discussed here, we'll take the derivative of the position, so it's going to be 2t minus 2. So what is the velocity after 3 seconds, for example? So x prime of 3, which is the same as v3, is going to be 2 times 3, 6 minus 2 is 4, for example, meters per second. Another question that we are interested in is how many times and at what point this particle changes its direction. So in order to change the direction, you need to stop. The particle must stop for a moment. So we need to set the velocity equals 0 to see where your particle stops. So when Vt equals 0, it means 2t minus 2 equals 0, and then t equals 1. So it means at t equals 1, particle stops, and then we want to know how does it change the direction. So 1 is here, so velocity is here. So if you plug in velocity, a number larger than 1, the derivative or velocity is positive, and then less than 1 is negative. So it means from t equals 0 to t equals 1, it means within the first second, the particle moves to the left side, it moves backward. But after 1 second, your particle, so it means from 0 to 1, you go backward toward the origin, and then at t equals 1, you stop, and then you change the direction and you'll go to the right side, as you see, because we noticed that at t equals 1, see, you're at t equals 0, you're here, and then at t equals 1, you're back, see, you're getting to the left side, and then after t equals 1 again, you move to the right side. So this brief video helps you to understand the connection between the equation of the position, velocity, and acceleration.